Here we're going to talk about angle relationships. So angle relationships show the connection between two or more angles. It shows how angles relate to each other. So adjacent angles are angles that share a side and they are next to each other. So angle APC and angle CPB, this one and this one, are adjacent angles because they are right next to each other and they have this common side. CP, this ray that I'm going to draw here, is the shared side between them. This set of adjacent angles also happens to be a linear pair because they are supplementary. Vertical angles are kind of the opposite of adjacent. They are across from each other and they are always congruent or equal to each other. So you can see this picture here, it's color coded. This angle is 130. Directly across from that, this angle is also 130. It forms an X, and on opposite sides of the X, we have vertical angles that are the same. Same thing with this angle and this angle. Those are both 50. They are congruent. So we can say, let's say I label this as angle A and this is angle B. I can say angle A is congruent to angle B. That is the sign for congruent in geometry. Complementary angles add up to 90 degrees. They might be adjacent. They might be vertical, actually. They don't have to be either one of these two, but they always add up to 90 degrees. So I have an angle here, DPC, and an angle here, CPB, that together they make this 90-degree angle. So these two angles are complementary to each other. We could also say they're complements of each other. Supplementary angles add up to 180 degrees, so together they make a straight angle. So actually I could use the angles from before, or I can use these two 90-degree angles. I have a 90-degree angle there, and a 90-degree angle here, APD, and DPB are supplementary. These two are also adjacent because they share that ray of PD. So these two are also a linear pair, but they don't have to be. If they are separated, they're just supplementary, just adding up to 180, not necessarily a linear pair. So it's especially important that we understand those relationships before we get into these trickier ones that deal with parallel lines and transversals. So a transversal is really just a line that crosses a system of lines. And a system of lines is really just more than one line. So this, I'm going to actually label this as line PQ. That is our transversal. And it's cutting across, let's just label these with one letter. That I'm going to call, actually I'm not going to put a point on there, line L and line M. So PQ cuts across these two lines. That's my system that I'm really referring to here, L and M, and PQ, that line, is the transversal. In this case, these lines are parallel, and the way I indicate that, I put an arrow on that, and I put the same arrow on this. Those lines are parallel to each other. You could also say L is parallel to M. That's not always the case. A transversal can cross two lines that are not parallel, but they have to be on the same plane, otherwise this line actually can't cross both of them like that. All right, so corresponding angles are a specific set of angles within this system that we kind of have set up here. They occupy the same position at each intersection. So angles 1 and angles 5 are corresponding angles. Angles 2 and 6 are corresponding. Angles 7 and 3 are corresponding. And 8 and 4 are corresponding. So you can see that they're in the same spot. These two are in the bottom right in that intersection, and that's the same kind of intersection here. That green angle 4 and this green angle 8 are in the same position. When these lines are parallel like they are here, then they are congruent. So in this diagram, I could say that angle 5 is congruent to angle 1. Corresponding angles are always congruent when the system is parallel, and vice versa. If I know this, that angle 1 and 5 are congruent, then I also know that these two lines must be parallel. Consecutive interior angles. So there's two big words there. Consecutive means that they are on the same side of the transversal. So, for example, anything on this side, all of these odd numbered angles here, those are consecutive angles. Interior means that they are within the system that I'm referring to in that first definition of transversal, within the system of lines. So they're inside, in this case, these two parallel lines. I'm going to mark that as parallel again. Inside here is where the word interior really comes from. And when the system is parallel, when these two lines I have here are parallel, consecutive interior would be referring to 3 and 5 or 4 and 6, and those are supplementary. So 4 and 6 are on the same side, and they're inside the parallel lines. 3 and 5 also on the same side as each other on this left side of the transversal, and they're inside the parallel lines. They are supplementary. They add up to 180 degrees. They are not a linear pair because they are not adjacent. Consecutive here still means the same thing. They're on the same side of the transversal, but now we're dealing with the exterior angles, which means they're outside this set of parallel lines. So angles 1 and 7 are consecutive exterior. Angles 2 and 8 are consecutive. They're still on the same side, but they are outside the system of lines. And when these lines are parallel, those angles are, again, supplementary. They add up to 180. Alternate means that they are on alternate sides of the transversal. They are on opposite sides of the transversal. Interior still means the same thing as before. That means they are inside the system. So we're only dealing with, when I'm talking about interior angles, I'm only talking about 3, 4, 5, 6. If I'm talking about alternate interior, really thinking about 3 and 6 as a pair, and then 4 and 5 as a pair. They are still inside the system, and these angles are congruent. And that kind of makes sense. Actually, if you look at this angle and this angle, together, this and this make a straight line. And together, that and that make a straight line. So these really have to be the same because they're adding up to 180 degrees with this angle 4 and, well, if 4 and 5 are the same, then 3 and 6 also need to be the same. This is not always true. If this system is not parallel, then these are not congruent. If this was tilted a little bit, then they would not be the same. Alternate, again, means opposite side of this transversal, and exterior means they are outside the system. So these are the far corners. 1 and 8 are a pair of alternate exterior angles. They're on the outside of this system, and they're on opposite sides of the transversal. One's on the left side, one's on the right side. Same thing with 2 and 7. And those are congruent angles. I could say angle 2 is congruent to angle 7, as long as I know that line L and M are parallel. Actually, these go back and forth. This logic can go either way. If I know that L and M are parallel, then I know that these are congruent. If I know that these are congruent, I guess I'm pointing at the wrong ones, but if I know that these are congruent, 2 and 7 are the congruent angles here, then I can actually also conclude that L and M are parallel.